Hey everyone, and welcome to this explainer brought to you by Forge College. Today, we're diving into what I like to call the inventor's blueprint. If you've been following along in the Solidity from Zero track, you know we're right in the thick of our data types, structs, and mappings module. And specifically, we've arrived at the capstone project. So, this explainer is all about defining your project scope and meticulously sketching out your smart contract architecture before you write a single solitary line of code. Because, in the Web3 space, planning your data layout up front, that's how we guarantee everything runs like a well-oiled machine when we finally hit deploy.
Okay, let's take a quick look at our schematic for today. We're going to get your capstone project out of the realm of raw ideas and map it out into a fully scoped data architecture. We'll start with moving from bugs to blueprints, meet the core materials, walk through our selection workflow, check out the master decision matrix, draft your design notes, and finally, blueprint that capstone. So let's jump right into section 1, from bugs to blueprints, where we'll be fixing that pesky zero mapping trauma. To give you some quick context on where we are on the map, this step is a absolutely crucial bridge in your learning journey. You've got the syntax down, you understand the basics, and now, right before you start implementing the comprehensive smart contract for your capstone, we're pausing, we're drawing up the blueprints. Jumping straight into code without doing this is basically a one-way ticket to expensive refactors later on.
I mean, we all remember the absolute trauma of default value pitfalls from our last lesson, right? You query a mapping for a missing key, it hands you a big fat zero, and suddenly your contract thinks an unregistered ghost user has an active balance. Total nightmare. But the good news is, deliberate planning right now is exactly how we exercise those logic bugs forever.
Moving on to section 2, meet the core materials. This is all about picking the right gears for the EVM.
First up in our engineering toolkit is the address type. Think of address as the essential ID badge for your contract. It's a 20-byte value mapping directly to Ethereum accounts. So whenever your domain property involves ownership, transferring value, or checking permissions, like, say, verifying if a user is an admin, this is your absolute go-to gear. It maps perfectly to the ABI, which makes off-chain indexing and signature verification a total breeze.
Next up is our numeric powerhouse, the uint256. You can think of this as the standard metric wrench for the EVM. Because the Ethereum virtual machine natively operates on 256-bit words, this just fits perfectly, making your arithmetic operations highly optimized. Now, actually, a super common beginner mistake is using smaller types like uint32, thinking it's going to automatically save gas. In reality, the EVM has to do extra work to pack and unpack those smaller types. So only drop down to smaller integer types if you are intentionally packing multiple variables into a single storage slot. Otherwise, uint256 is your default.
Now check this out. Using a dynamic string on-chain is literally like building a basic, everyday gear out of solid gold. Sure, it works, but it's incredibly heavy, and it costs an absolute fortune in gas fees. On the flip side, bytes32 is a highly efficient, fixed-size barcode. If you need an identifier, just hash it into bytes32. It's sleek, it's cheap, and it's perfectly optimized for lookup keys.
All right, section 3, the type selection workflow. We need a repeatable process for every single field.
To build a robust contract, you really need a reliable assembly line. Run every field through this strict 5-step sequence. 1. Identify what operations the field needs. 2. Choose a primary candidate type based on that. 3. Consider the gas and access characteristics. 4. Add defensive metadata. And 5. Capture how this choice impacts off-chain integration. Sticking to this assembly line guarantees you won't run into unintended overwrites or nasty integration surprises when you're hooking up your front end later.
Let's make those 5 steps even easier. Welcome to section 4, the master decision matrix, basically the cheat sheet for your capstone.
Notice how standard domain properties map instantly to specific materials here. Got an account or an owner that needs authentication checks? Boom, recommended type is address. Got a counter or a quantity that requires arithmetic? Map that instantly to uint256. Following this matrix gives you gas-efficient, direct ABI integration without overthinking it.
And for the rest of the metrics, when you're dealing with external identifiers used for lookups and keys, always prefer bytes32 for compact storage. As for human text, like descriptions or bios, try to keep that bulky text off-chain whenever possible. Maybe store a hash or a URI on-chain instead. If you absolutely must have it on-chain, well, use string or bytes, but just be prepared to pay that gas premium. Keep your on-chain storage as lean as possible.
Okay, section 5.
drafting your design notes. It's time to actually document your engineering choices.
As you start inking out your notes, every single variable in your blueprint has to clearly answer 3 core questions. What functions modify the field? What off-chain query fetches it? And, absolutely crucially, is there default value ambiguity? Documenting this up front ensures your off-chain indexer can actually read the data you write, leaving 0 logical holes in your state. And this brings us right back to our debugging lesson. If your mapping can return an ambiguous default value, like returning a 0, when 0 could also be a valid intentional value, you literally must add an existence flag. Using a struct that includes an explicit bool exists marker completely eliminates that whole class of bugs where you're just left wondering if data is missing or just 0.
So, to formalize all of this, here's the exact template you're going to use for your upcoming exercise. You'll document the trade-offs for at least 3 core entities in your capstone project. You just need the field name, the chosen type, the specific operations, and a short rationale explaining the gas impact, ABI integration, or safety measures.
Let's look at a completed one in action. For the field name item owner, the chosen type is address. The rationale explicitly tells us why. It maps cleanly to the ABI and allows gas-efficient permission checks. And I love this part. The note explains that the heavy lifting for human-readable display names is actively pushed off-chain for the UI to handle. That is exactly the kind of deliberate engineering choice we want to see. Finally, Section 6, Blueprinting your capstone. You are ready for construction. Carry these 3 golden rules with you into your project. 1. Rely on native EVM types, defaulting to address and UN256, unless you have a heavily documented slot packing strategy. 2. Use defensive mapping flags to destroy default value ambiguity. And 3. Rigorously keep bulky text off your contract using bytes 32 hashes for identifiers. Completing this field-by-field table sets you up absolutely perfectly for our very next lesson, where we'll take these isolated choices and compose them into advanced struct layouts and complex mapping relationships. We take the basic gears and we finally assemble the engine. So I'll leave you with this thought. Is your smart contract going to run like a well-oiled machine, or will it run out of gas on day 1? The choice is entirely in your blueprint. Make sure to finalize those design notes using the template we covered today. Thank you so much for joining me for this explainer, brought to you by Forge College. Be sure to visit forge.college to explore more Web3 resources and keep sharpening those skills. Happy blueprinting, and I will see you in the next one.